Hello, welcome everyone. Now we are going to explain flotation. So this is a very interesting chapter and I am going to deal flotation. Flotation. So first I am going to discuss thrust and pressure. In this chapter we shall study about thrust and pressure, density and relative density, pressure in fluids, buoyant force or upward thrust, cause of buoyant force, mathematical expression for upward thrust, factors affecting buoyant force, Archimedes principle, principle of flotation, and so many things. So first I am going to discuss thrust and pressure. So the thrust, the net force acting on an object perpendicular to the surface is called thrust. Suppose this is a surface, right? And you are applying force on this in this manner so that force is 90-degree on the surface. So this is known as thrust. In this case this force will be said to be what? Thrust. So if force is at 90-degree from the surface, this is surface, then it will be said to be what? Thrust. And the normal force, the normal force per unit area, per unit area is called pressure. Now I am going to illustrate certain situation. Uh, when we fix a poster on a bulletin board, we press a drawing pin by applying a force with our thumb on the surface area of its head. This force is directed normal to the surface area of the board and acts on a smaller area at the tip of the pin. Example, certain examples. When a person stands on dry sand, his feet go deep into the sand because his body weight is acting on an area equal to the area of his feet. If the person lies down on the sand, you will find that the body of the person doesn't go that deep into the sand. Why? Because this time area of contact is larger than that of the feet. It is observed that the effect of the same force, that is weight of the person in this case, on different areas are different. Now since thrust is a force acting on the body perpendicular to its surface area, what I am telling you is that thrust is a force acting on the body, on the body perpendicular, perpendicular to its surface area. Surface what? Area. Thrust exerted on the sand is the weight of the person. The effect of thrust depends on the area on which it acts. Now I want to tell all of you is that thrust is a force, therefore its SI unit is same as that of force, Newton. Pressure. So pressure, how it is defined? It is thrust upon area, and thrust means perpendicular force. Thrust means perpendicular force. So of course SI unit of pressure is SI unit of pressure Newton per meter square. Newton per meter square, and it is given a specific name, Pascal. Pascal. On the in the honor of the scientist Blaise Pascal. And 1 Pascal is equal to 1 Newton per meter square. For meteorological purpose, the unit of pressure is taken as bar. 1 bar is equal to 1 bar is equal to 10 raised to 5 Pascal. Pressure depends on so many factors. So pressure dependence of pressure. First, pressure is directly proportional to thrust when area is fixed. If area is fixed, so of course if force will be more, pressure will be more, and if force will be less, of course pressure will be what? Less. Second factor, pressure is inversely proportional to area if thrust is constant. Okay, that means if area will be more, pressure will be less, and if area will be less, then pressure will be more. Okay, example, cutting edge of knives are sharp. Why? Some examples. When we cut fruits or vegetable with knife, we push the knife normally into them. Pressure is inversely proportional to the area of contact. Sharper the edge of a knife, more is the pressure it exerts on the vegetable for the same amount of force applied. Hence, it cuts better. Second, pins and nails have pointed ends. Why? Pins and nails have very small area at the tips due to their pointed ends. A small force on the head of the pin or nail will fall on a small area of the surface, like cardboard of notice board, thereby exerting necessary pressure to drive it into the surface easily. Third example is board handle are provided. We have already illustrated 2 example. This is third example. Broad handles are provided in bags and suitcase. Why? Due to broad size of handle, the area of contact increases, which reduces the pressure exerted by the weight of the bag or suitcase. Next, fourth, skiers use long flat skis to slide over snow. The long flat skies increase the area of contact, which reduces pressure because pressure is inversely proportional to area. So pressure exerted by the skier on the snow, enabling the skier to slide over the snow without sinking. And fifth, railway tracks are laid on larger sized wooden or concrete sleepers. Due to wooden or concrete sleepers below the railway tracks, the weight of train acts on the greater area of contact, and hence it reduces pressure appreciably. As a result, the rails do not get depressed. In absence of the sleepers, the weight of the train acts on the ground and the pressure would be so large that the rails may get depressed into ground. Now I am going to discuss density and relative density. Density and relative density. What is this? If we take two balls of the same size, one made up of iron and other of plastic, of course iron ball is found to be heavier. This can be better understood with help of an important physical quantity, density. Density is defined as the mass of a substance per unit volume. It is different for different substances. Mathematically, density is equal to m upon v, where m is mass of the substance and V is the volume of the substance, and its SI unit is kilogram per meter cube. It can also be measured in gram per centimeter cube. So density of a body depends upon, first, D is proportional to mass. If V is fixed, V means volume is fixed, so more the mass, more density. Less the mass, less density, provided volume is fixed. So as the mass increases, density of the substance increases for constant volume. That's why iron ball is heavier than plastic ball. And second, volume density is inversely proportional to volume if mass is fixed. So if volume will be more, density will be less, and if volume will be less, density will be more, provided mass is fixed. So as the volume increases, density of the substance decreases for constant mass. Now density is the characteristic property of the material of a substance. The density of a substance remains constant under a specific conditions. Two objects made of the same material have the same density even though they may have different masses and different volumes. That's because the ratio of mass to volume is same for both objects. One more thing is relative density. And what is this relative density? Relative density. So relative density of a substance is defined as the ratio of the density of the substance to the density of water at 4 degrees C. So relative density RD is equal to density of a substance divided by density of water at 4 degrees C. This is important thing. Or relative density can be expressed mass of the substance upon mass of an equal volume of water at 4 degrees centigrade. Or relative density can be expressed as weight of the substance divided by weight of an equal volume of water at 4 degrees C. So this 4 degrees C is important because anomalous behavior factor. Now I want to tell all of you that density of water is 1 gram per centimeter cube in CGS system. So relative density of a substance is numerically equal to its density in CGS system. Now I want to discuss pressure in a fluid. Pressure in fluids. Fluid is a name given to any substance which has no fixed shape and has the ability to flow. All liquids and gases are fluids. Okay. We have studied that a solid exerts pressure on another surface on account of its weight. Okay. Similarly, fluids have weight and they also exert pressure on the base and wall of the container in which they are enclosed. Suppose this is container. Okay, this is container, and in this suppose some liquids are placed. Some liquids are placed. In this case, fluid exert pressure. So fluid is exerting pressure perpendicular to the surface, and here this always perpendicular to the surface. Whenever pressure is applied, this is your container, this is your container, and this is your fluid. Okay, so whenever pressure is applied anywhere on a confined fluid, it is transmitted undiminished in all directions throughout the fluid. Molecules of a liquid exert great repulsive force when they are pushed closer to each other than their normal distance. Due to this property, liquids cannot be easily compressed by application of thrust on the surface. Okay. Thus, force applied on a liquid surface is immediately transmitted to every part of the liquid. This may be demonstrated by filling a long necked bulb having a number of tubes connected to it with water. When pressure is applied on the water by pushing the piston fitted in the neck of the bulb, water rises up to equal height in all the tubes. What I am telling you is like this. Suppose this is the situation. This is the situation. I am trying to draw it. Okay. This is the case. So this is, so when we are applying, this is piston. Okay, so this is piston. So in all cases, if we press it, in all cases fluid will be at same height. So when piston will be here, situation will be like this. When we will press it, so in all cases the height of the liquid in all pipe will be same when we will press it downward. Okay, so this can be summarized in Pascal's law as the external pressure exerted on a confined fluid at rest is transmitted unchanged and equally in all directions. This is known as Pascal's law. Now, one more thing I would like to tell all of you is that suppose this one is a container. Okay, this one is a container in which some liquids filled, and we have considered this is the height of liquid, so we have considered an area this. Okay, so we have considered this much liquid which is h, whose bottom is at h height below, and this is free surface. This is free surface. Above it is free to atmosphere. Okay, so pressure at depth h, at this level pressure at depth h, in this case we have considered that there is no atmospheric pressure, so in this case pressure at depth h is hdg, where h is depth, d is density, and g is what? Acceleration due to gravity. And in this case we have assumed that atmospheric pressure is 0. Second thing is that uh, conclusions. Pressure exerted by liquid at a point inside it is directly proportional to the depth of the point, density of the liquid, and acceleration due to gravity. This is quite clear from this expression. And pressure is independent of the amount of liquid, shape of the container, or cross sectional area considered. So if a given liquid is filled in a vessel of different shapes up to the same height, the pressure at the base in each vessel will be same, though the volume of weight of the liquid in different vessel will be different. What I am telling you is that suppose this is a vessel 1, this is a vessel 1, this is a vessel 2, and this is vessel 3, and in all the height of liquid is same. This is h, and in this 2 this is h, this is also h. So in all cases the pressure at bottom, suppose this is point A and this is point B and this is point C, since height is same, so pressure at A is equal to PB is equal to PC. So pressure at all points A, B, C are equal in all three vessels because the height of the liquid in the vessel is same. From the relation P is equal to HdG, we find that pressure at a given point in the liquid is uniquely defined. If the pressure at point is P and you keep a small surface of area A, at that point the force exerted by the liquid on this surface has the magnitude F is equal to PA, because pressure is equal to force upon area, so force will become pressure into area. This force always acts perpendicular to the area. There are two rules that you should remember. First, two rules that we should keep in our head. First, the pressure in a liquid, the pressure in a liquid is same at all point at the same horizontal level. And second, as we go deeper in a liquid, the pressure increases. The pressure what? Increases. So now that's why divers know this quite well. These rules sea divers know quite well. They wear armored suits while diving because 1,000 meters below the ocean surface, an armored suit protects the diver from being crushed by the immense pressure of water. As the pressure deep inside the ocean is over 100 times greater than the pressure at the surface. Okay. Now one more important thing is buoyant force. Buoyant, B-U-I-T, force or upward thrust. And what is this? If we lift a stone lying at the bottom of a pond, it appears to be light as long as it is being lifted inside water, but as soon as it is lifted out, the same feels much heavier. Why? Answer to this question be can be better understood by the new concept buoyancy. So every fluids exert an upward force on a body immersed in it. This upward force is called buoyant force or buoyancy. So every fluid exerts an upward force, on a body immersed in it. This upward force, this upward force is called what? Buoyant force or buoyancy. Okay, for example, when an object is immersed in a liquid partially or fully, it displaces some of the liquid. The liquid has a tendency to regain its original position, due to which liquid exert an upward force called upward thrust or buoyancy. So I am telling you that suppose you have liquid and this is spring balance, and if you have kept an object, this is object and this is spring balance, so what weight it is measuring outside when you will place, this is liquid, when you will placed in this which is liquid, in this case this spring balance will measure less weight. Suppose it is measuring 150 gram earlier when it was not dipped in liquid, and when it is dipped, now its weight is 140 gram. Okay, so from this we understood all these things. So conclusion is that we can conclude that as more and more volumes of an object is immersed in a liquid, the apparent weight of the object goes on decreasing and it seems to become more and more lighter. But once the object is completely immersed in the liquid, then further lowering it in the liquid does not make it any more lighter. This means that maximum loss in weight of an object take place when it is fully immersed in a liquid. Now question is that what is the cause of buoyancy? Cause of buoyant force. Suppose this is a bucket in which you have kept a mug. This is mug. Okay, so liquid exerts force from all direction perpendicular to it. This is water, because in this water is filled, this is filled inside water, so this is water. So when a mug filled with water is immersed in a bucket containing water, water exerts force on the sides of the mug as well as on the top and bottom. The sideways force exerted by water on the mug being equal and opposite cancel out. The force of water acting on the top of the mug acts in downward direction, and a force of water acting on the bottom of the mug acts in upward direction. As we know that the pressure exerted by liquid in depth is greater than that on the surface of the liquid, that is at the top. Suppose this is top, so here pressure is less and at bottom pressure will be high, because as we go down pressure increases, so it experiences less downward force. The bottom B, this is bottom B of the mug is at greater depth in water, so it experiences greater force at B in upward direction. Okay, thus there is a net upward force on the mug. This net force acting on the mug is in upward direction is called buoyant force, which reduces the effective weight of the mug and it seems lighter. So the force acting from left direction and from right direction cancel out. Here pressure is less and here pressure is more. So a net upward force is acting, known as what? Buoyancy force. So now I am going to discuss factors affecting buoyant force. Factors affecting the buoyant force. First, the buoyant force exerted by a liquid depends on the volume of the solid object immersed in the liquid. Second, buoyant force is directly proportional to density of the liquid in which the object is immersed. Third, buoyant force is directly proportional to acceleration due to gravity. Fourth, buoyant force is inversely proportional to the temperature of the fluid because density decreases as temperature increases. Okay. Now one more thing is Archimedes principle. So what actually Archimedes principle? So when a body is partially or fully immersed in a fluid, it experiences an upward thrust which is equal to the weight of the fluid displaced by the immersed part of the body. That is buoyant force acting on the body is equal to weight of fluid displaced by that body. Okay. So application of Archimedes principle. What is application of Archimedes principle? This principle is used to design ships and submarine. Second, it is used to determine the relative density of a substance. Third, the hydrometers used to determining density of liquids are based on this principle. They are also used to find the relative density of a liquid directly without any calculation. And fourth, lactometers are based on this principle and they are used to measure the relative density of milk. Okay. Now, principle of flotation. Principle of flotation. So, principle of flotation is a thing made up of wood floats over the surface of water, but a small pin made up of iron, when put on the surface of water, sinks to the bottom. It can be understood by considering the number of forces acting on a body when it is immersed in a liquid. When a body is immersed in a liquid, there are two forces acting on the body. So I am first is weight of the body acts vertically downward. Suppose this is a beaker in which liquid is filled, and there is a body which is immersed in it. So there are two forces acting on it. This is W2 and this is W1. So W2 is upward thrust, upward thrust, and W1 W1 is what? Weight of the block. So first is weight of the body acts vertically downward, which has tendency to sink the body in the liquid due to gravity. And second is upward thrust of the liquid acts vertically upward, which is equal to the weight of the liquid displaced by the immersed part of the body. This force has a tendency to push the body out of the given liquid. Laws of flotation. Laws of flotation. And what is this? Suppose this is a container in which liquid is filled, and there is an object whose density is d1 and liquid has density d2. Okay, so body is experiencing two force, w2 and one is w1. So if d1 is greater than d2, that is density of object is greater than density of fluid in which they are submerged. So v into d1 is greater than v into d2. So where v is what? Volume of block. So of course mass of the block is greater than mass of the liquid displaced. Okay, so that is v into d1 into g is greater than v into d2 into g, that is w1 is greater than w2. Second thing is, this is first case I explained. I am trying to explain through second example. This is your beaker in which liquid is filled, and there is an object which is in this situation, and density of object is d1 and density of liquid is d2. So w1 is acting vertically downward and w2 is acting vertically upward. Since it is floating means it is in equilibrium, that means w1 is equal to what? W2. And this is possible if d1 is equal to what? D2. So when density of body and density of liquid, so this is density, d2 is density of what? Liquid. And d1 is what? D1 is density of body. In this case, when density of body and density of liquid or weight of the body is equal to upward thrust, then the body will float just below the surface of the liquid and apparent weight of the body is zero. The body will be in the weightless condition. And third is like this situation in which liquid is filled in the beaker and a body is floating but not fully. Some portion of the body is outside. So density of body is d1 and one force is w1, and density of liquid is what? d2, and other force is w2. Here w1 is less than w2 as d1 is less than d2. So that means when density of the body is less than density of the liquid, the weight of the body is less than upward force of the liquid on completely immersed body. The body will float partially above the surface of the liquid when released free. Here W2 is what? Is the upward thrust when body is immersed completely in liquid. Okay. So ice, wood, cork, plastic, etc. have density less than that of water, so they all float in water. Okay. Okay. Now application of laws of flotation. So first application is, what are the applications applications of laws of flotation. Laws of flotation. So an iron nail sinks in water while a ship made of iron does not sink and keeps on floating. This is because weight of iron nail is greater than weight of water displaced by it. So it sinks into water. Whereas ship is made hollow from inside, which reduces the average density of ship than that of water. So it floats on the water. Therefore, even for a small part of ship submerged, the weight of the water displaced becomes equal to the weight of the entire ship, so it keeps on floating. Second is flotation of icebergs. The density of ice is 0.917 gram per cm cube, which is less than density of water, 1 gram per cm cube. This is of water and this is of what? Ice. Hence iceberg floats on water. Third, flotation of man. The average density of human body is about 1.07 gram per cm cube with empty lungs. When lungs are filled with air, it is 1 gram per cm cube. Seawater is more dense as compared to human body, so we can easily swim or float in seawater. Next is fourth is flotation of fish. So many species of fish have the ability to increase or decrease the volume of its body by a compressible organ called swim bladder. In order to calm down the gases from swim bladder, diffuse and fluid comes into bladder which increases its mass. As a result, weight of the fish increases and the fish comes down. In order to raise up, the water is removed from its bladder and gas rushes into it, which reduces its mass. As a result, its weight decreases and fish rises up within the water. So I want to recap it very quickly. So we studied thrust. The force acting on an object perpendicular to its surface is called thrust. Thereafter we studied pressure. The thrust per unit area is called pressure. It is a scalar quantity and its unit is Newton per meter square or Pascal. Thereafter density, and we defined it as the mass of the substance per unit volume. Thereafter we did discuss relative density. It is defined as the ratio of density of the substance to the density of water at 4 degrees C. Thereafter Archimedes principle. When a body is partially or fully immersed in a fluid, it experiences an upward upthrust which is equal to the weight of the fluid displaced by the immersed part of the body. And thereafter at last we did discuss laws of flotation. When a solid floats in a fluid, then the weight of the floating body is equal to the weight of the liquid displaced by the immersed part of the solid. So thank you so much to all of you.